Alright, so we're looking at problem number 5 now. This is the one that we had the issue with me not telling you enough information. So, if a flea can jump straight up to a height of 0.44 meters, so we're looking at a flea that's jumping straight up, and the top of its trajectory right here is our delta x, because that's what the height is. And then it's going to come to a stop, and then it's going to come straight back down. So we're not worried about this leg on the way down, but we are concerned that the velocity changes directions right here. And when velocity changes directions, right at that moment, our velocity is 0. So since we're dealing with this leg from this start to this finish, we can call this our initial velocity, which we're looking for, and this is our final velocity up here. So we have a delta x given to us of 0.44 meters. We know our final velocity is 0 meters per second, once again because we're changing direction. And we know since it's flying through the air basically, the only thing acting on it is gravity. And so that's where our acceleration comes from, which is negative 9.81 meters per second squared. So we want to know our initial velocity, how fast the flea starts out jumping to make it to that height. So our initial velocity is question mark in meters per second. And it also asks us for time. And we'll find that in seconds as well. Alright, so if we look here, we have our kinematic equations, and hopefully this works on the video. So if we look here, we need initial velocity and time. So if we see both of those variables in any given equation, we know we can't use it. So here, initial velocity initial velocity and time, initial velocity and time, we can't use those. So we're stuck using this final equation number 4 right here. So we're going to solve this for the initial velocity there. So we have Vf squared equals V naught squared plus 2a delta x. We're going to solve this for the initial velocity, which I'm going to skip the steps of the algebra, but V initial is the square root of Vf squared minus 2a delta x. Alright, Vf goes to 0 because we have a final velocity of 0. So we get the square root of a negative 2 times negative 9.81 meters per second squared times our delta x of 0.44 meters. So if we throw that into our calculator, we get the answer 2.94 meters per second. And that's our first answer for A. Now that we have an initial velocity and we're looking for time, we have 4 pieces of information about it, and we're just looking for the 5th one. So pretty much any equation will do. The easiest will be Vf equals V naught plus AT, and we're going to solve that for time. So time Vf minus V initial divided by A. And we get our final velocity is 0, so minus 2.94 meters per second divided by a negative 9.81 meters per second squared. And so you see we get negatives cancel out. We don't want a negative time. Plug that into our calculator, and it is it's really close to 0.3 seconds. And that's our final answer right there. Okay.